Today, Open Source Security is talking to Paul Kehrer and Alex Gaynor, the maintainers of the Python Cryptographic Authority. Paul and Alex were kind enough to join us. They wrote a blog post about OpenSSL that's kind of taken the internet by storm. So I want to thank you both for being here. And since Paul is the leftmost on my screen, I'll say, Paul, why don't you kind of introduce yourself, and then we'll go to Alex and we'll go from there.
Absolutely. So as you already said, I'm Paul Kehrer, and I'm one of the co-maintainers of the Python Cryptographic Authority. Our principal library is kind of the de facto standard Python cryptographic library. And in a feat of hubris back in 2013, when we first started this project, we named it Cryptography, thus ensuring that no one could ever Google for it. It's maintained like I maintain this in my spare time, along with a few other libraries, and it's kind of a passion project. Yeah, and I guess that's about it. I'll pass it to you, Alex.
Yeah, along with Paul, I'm the I guess other principal maintainer of the Python Cryptographic Authority. Paul and I, maintain this in our spare time, so we're not speaking on behalf of our employers here. Yeah.
Okay, so let's just start out by first saying what is. I'm just going to call it cryptography because that's what I have in my brain, since that's what it. But what is cryptography? Like, what does it do? And why would anyone use it?
Yeah, so cryptography is a Python library that provides kind of access to cryptographic algorithms like RSA or AES, as well as like file formats that are widely used in cryptographic ecosystems, things like X509 certificates. So like you would pretty much use this if you're doing almost anything cryptography in Python, with the exception of TLS, which we don't have APIs for. So if you're encrypting things, if you're signing things, issuing certificates, anything like that, you're likely to use us. We're like the Let's Encrypt command line tool uses us, Certbot, like lots of tools like that use us.
Cool, right on. And we'll start with your blog post and go from there. But I don't know. Is it a blog post? It's in a statements. It says on your website. So
yeah. So the Python Cryptographic Authority has never written a blog post before,
okay.
and we don't really want to operate a blog.
Fair enough.
And accordingly, like we've had this conversation kind of going in the background for quite a number of years. We know a bunch of the OpenSSL maintainers. They invited us to talk at their conference where we gave the visual and audio form of this statement. But as we wanted to move on and figure out what it looked like to have a broader audience for what we have, for the concerns that we have around this, we thought we need a venue to publish it. Alex and I talked a little bit about whether it belonged on our personal blogs, and we decided no, it has a lot more power as a joint statement coming straight from the project itself. So we had to create a new section on our documentation website.
And I will add, this is the only statement that you have on your documentation.
That is correct.
Okay, so the title here, it says the State of OpenSSL for pyca/cryptography. And I will let the two of you explain this statement because I feel like it's relatively powerful. And I think you hit on a lot of things that a lot of people in the industry have kind of been, whinging about for years and decades, honestly, about OpenSSL. So I'll let the two of you argue over who starts and go from there.
Sure. So Alex, I think what I'll do is I'll start with a quick recap of why we consume it and why we care, and Alex can kind of move into the set of concerns that we have around this. So when the Python cryptography project was started, we very consciously made a decision that we did not want to be implementing cryptography ourselves. Now, there's a lot of nuance around what is and is not cryptography, and those boundaries have become more fluid for us over time, especially as Alex and I, whether or not we want to admit it, are largely cryptographic engineers in these days. However, OpenSSL was and remains the de facto standard across the industry for open source cryptography.
Yep.
It provides FIPS compliance environments where you need it, and it's installed by default effectively in every distribution, and including even in macOS at the time when we were shipping. Accordingly, we based ourselves on top of it. When we started, we actually supported all the way back to OpenSSL 098. And
Wow.
then we moved, and we were running through 098 through 101, and then we moved into 102, 110, 111, and then moved into the OpenSSL 3 betas and alphas, where many of our largest concerns began. So from there, I'll actually pass it over to Alex, and we can talk a little bit about what those concerns actually look like.
Yeah, as Paul said, maybe the way I'll contextualize this is I think many people's negative experience with OpenSSL date to the Heartbleed era back in 2014.
Yeah.
But for us, for many years post Heartbleed, OpenSSL got better, right? OpenSSL got new resourcing, which it used to improve testing, add important missing APIs. And then OpenSSL started the OpenSSL 3.0 process, which was really a big rethinking of their internals as well as their public APIs. And for us, OpenSSL 3 became a quite negative experience in a couple different dimensions. So what we found is the public APIs got a lot more complex, a lot less ergonomic, a lot harder to use. The internals of OpenSSL became much more difficult to trace and read. I think many people who are advanced consumers of libraries they use will probably have the experience of, sometimes I just have to read the source and not just the documentation to know how it works. And we found the, just go to the source became a lot more challenging with OpenSSL 3. And OpenSSL 3 also significantly regressed performance. Many important operations you might do, like loading parsing a key, became a lot slower. And at the same time, it didn't make progress on things we think are really important, improving the state of testing and formal verification of OpenSSL, or making progress on stronger approaches to memory safety in OpenSSL. So for kind of these set of reasons, we've kind of had growing levels of concern about OpenSSL 3, particularly how good a fit OpenSSL 3's development direction was for our library. And we found there's just increasing divergence between what we want in a cryptography library and the directions OpenSSL is taking.
Sure.
Yeah. And one thing before we move on, I just want to quickly note, Alex mentioned performance, and one of the things that we found in the wake of publishing this statement is that various groups have, I think, over-indexed on our performance concerns. Performance is, of course, important, but that is not the primary criticism we have. That is just a result of the complexity and other things that we have seen occur over time.
Right, for sure. And I know you are not the only group of people I've heard complain about the performance of OpenSSL 3. I think it was Daniel Stenberg, the curl maintainer, way back in the day, was complaining about how much slower it is. So anyway, and I want to also bring up one of the things you note in your document here is OpenSSL isn't the only game in town anymore. Back in 2013, when you folks started this, it probably was. I don't think, because really the forks came after Heartbleed, if I recall correctly now.
Yep.
That's right. So let's talk about some of the what other things are there out there, right? Because you can, if you wanted to, it would hurt, but you could move off of OpenSSL at this point in time, whereas when you started, that was not a realistic scenario.
Yeah, that's right. So the time we started, there just was only OpenSSL. There were no forks. And I will say, originally when the forks started, we did not want to maintain support for them. That felt like a lot of extra work for not a lot of benefit. But over the years, we have added support for LibreSSL, Boring SSL, and AWSLC to the point where, if you want to bring your own of any of those, we'll work with any of them. I guess just in terms of the state of them, we think those are all pretty good libraries. They all have I guess pretty different philosophies across many axes. LibreSSL, I would say, is much less performance oriented. Right, they're less likely to have the specialized assembly for the latest Intel CPU or something like that. Boring SSL is very clear, they do not commit to any API stability for anyone who is not Google, right?
Right.
Is you may look, you may not touch or something, but we think it's a really high quality library, notwithstanding that. And AWSLC is actually a fork of Boring SSL, but they have committed much more strongly to they intend this to be a widely consumable library. I don't know what else you'd say about them, Paul.
The only other thing I would say is that each one has taken somewhat different approaches to the API surface area that it chooses to expose. So you have like you obviously they have they all diverge roughly at the same time, which is to say they have an OpenSSL 1.02/111 style API.
Yeah.
None at this time, none of the forks have adopted OpenSSL 3 APIs, although there are some small steps towards at least some pieces of that for some of the forks at this point. And then some of them have significantly diverging APIs, especially in the realm of things like post-quantum cryptography. So MLChem and MLDSA are areas where we may have permanent divergence.
Yeah. And the other thing that I think is really cool is it's Amazon, and is it Boring? I can't remember the other one, but two of them have formal verifications of their crypto code, which is
AWS-LC and Boring both have
Boring
formal
does, okay.
verification for subcomponents. So Boring has fiat crypto for like basically the field arithmetic and elliptic curves. And then I don't actually recall exactly what AWS-LC has, but they have some formal verification in quite a few places.
Which you should correct me if I'm wrong, because my understanding is a formal verification is you think of it as like a mathematical proof where they have proved that the code is correct and it actually does what it's supposed to do, versus kind of a lot of computer code, which is we think it does what it's supposed to do. It passed the tests. It's probably fine, right?
Yeah, I mean, that's basically right. There's several different approaches to how people do formal verification. Like the fiat crypto Paul mentioned actually works by you write your like field arithmetic in a specialized language, and then it generates C code from the formally verified stuff that it's kind of like its own compiler, as opposed to like attempting directly formally verify your C code or something like that. But yeah.
So that, and AWS-LC has, I think they have a mixture, but like certainly one of the AWS has had a relatively heavy approach, especially in S2N, which is their TLS library, around having code and having formal verification language, and attempting to make sure those things stay in sync, which is a challenging thing of its own, where sometimes the proof does not actually match the implementation. So like Alex and I have something of a bias towards things that can generate things from the formally verified language, but that is actually a challenging and active area of research that folks like the high assurance crypto seminar, like hacks, spend a lot of time thinking about how they can do better at that.
That's fair. And that's like a whole, it's beyond my realm of understanding, but I find it fascinating. I know I talked to the Rust TLS folks on the show a couple months ago, and that's one of the things they mentioned is they're using the formally verified libraries from Amazon in their project, which is super cool. I mean, I love hearing about that kind of stuff. So, okay, before we kind of dig into some of this, I want to ask, so you said you were at the OpenSSL conference, which was in Prague, if I'm remembering correctly. I had them on the show actually right before their conference, and they were talking about it. And how did they take this feedback? Because I know one of the things like we discussed was their desire to kind of, talk to the community and understand what people are saying, because like the OpenSSL project they recognize like they have many sins in their past, and they're very good about that. Like I feel like they have a very good attitude, but I'm curious how these were all taken.
Yeah, so we were directly invited by the OpenSSL Foundation for this talk. Like we're significant consumers of theirs; they're aware of it. We actually exist inside their CI as a component of their regression testing suite. Although some of the things that they regression test are things we've been reducing our own surface area dependence on OpenSSL on for quite some time. But Matt Caswell, the president of the foundation, was very receptive. I mean, I want to make sure that we're very clear that like the OpenSSL folks have actually been extremely polite in all forms. They invited us directly into their home. We told them it would be a critical talk. They welcomed the critical talk. When we provided the talk, we had multiple OpenSSL developers in the room, and there was no ill will. But our concerns around this are such that while the project does acknowledge its faults, it acknowledges the challenges it has, it acknowledges its history, like those, acknowledging it is not an excuse for not changing behavior in the future.
Right. And it should also be mentioned, you two are functionally volunteers here. You're not being paid to put up with this crap, right? Like you're doing this in your free time. So there's also something to be said about using libraries that will say respect the time of the people using them, right?
Yeah, I think it's definitely right. Paul and I both work on cryptography in our free time, and I think kind of the way we maybe the shortest way of saying it is like, if you have like a professional security team, like you think about like shifting left to like maximize developer productivity, right? Like you don't want surprises in production or things like
Yeah,
that. Like
yeah.
we don't want, we want all of our development to be like on our schedule. So like, bad experiences or like needing to respond to vulnerabilities or API changes are all like, things you want to like avoid in your hobby.
Yeah, that's fair. That's fair. Okay, so I'm looking at your piece here, and you start out with performance, which we kind of talked about. You talk about complexity and APIs, which you touched on a little bit, but you have a section called testing and verification. And this is one of the things I wanted to talk to you two about, because I actually don't really know. I know very little about what you're doing in your CI environment. And there's somewhere in here, you started at the beginning. We have a joke that the Python Cryptographic Authority is a CI engineering project. And so, like, explain what that means to anyone listening who might not understand.
Yeah, I mean, it means we spend a lot of time, polishing our continuous integration environment. It's Paul and I will meet at PyCon most years, and we'll work on cryptography together there. And for several years in a row, all we did more or less was revamp and improve our continuous integration. And like our theory there is like, if our continuous integration is great, anytime we're spending on the library will be like, time well spent. We'll have really high confidence in what we're shipping. We won't have regressions. We'll catch bugs or performance issues like very early. And they're just, no surprises. No surprises later. No, we issue a release and people show up saying, why is it broken? Well, we get that sometimes, but it's for things that were intentional, never by accident, more or less. And so we think it's really important to shipping, high quality software. Cryptography is in many ways more testable than many other things you could do, right? We have large volumes of kind of known answer tests where like you run the encryption, you run the decryption, and you check the results. Like getting to something like 100% coverage on your code is like very straightforward. There are challenging areas like constant time testing, but like in the main, like testing that something is like correct at least is like a quite tractable thing, we think.
Right on. And I feel like cryptography is one of those places, like, when you make mistakes, it goes sideways really fast, right?
That's true. It's also the case that a lot of the time the difference between cryptography that works and cryptography that doesn't is invisible, right? Like a broken encryption that round trips correctly looks the same to a developer as one that does work correctly. And so it's very important that the APIs are both designed in ways that minimize the ability to shoot yourself in the foot, and also that the underlying primitives simply work the way you expect, regardless of the platform or the endianness or whatever CPU architecture you might be operating on, within the bounds of what we consider supportable, which is largely the set of architectures that have LLVM ported to them.
That's a good point, because I know I've done a lot of security work and I've dealt with a lot of security vulnerabilities. And more than once, we've seen instances where developers like thought they were setting the key and they weren't, or they had no initialization vector or whatever. And yeah, there were like, for years, the application had functionally no encryption on over the network. And like literally no one knew, because the people who could figure this out, there's 6 of them on the planet. And they never looked, which I get.
Yeah, and the language also can cause you challenges there. Like, for example, if you were to do this sort of work in C, you're gonna set up a byte array, and if you forget to populate that byte array, well, then it's going to be either garbage or maybe it's been null initialized. But either way, like there's some bytes there, and it's going to use them, and so like you will get no errors. It will process.
Yes.
Yeah, and I would say like particularly as you kind of go up the cryptography stack, right? Like, above your like core AES implementation, you got all of these like file formats, things like X509 or PKCS7, and those are like extremely testable. Like those are just like, if you were just like, I don't know, like teaching a class on like good testing, like you might use these because they're like the perfect examples of like, it's a self-contained file format. It's like well documented. You can know like exactly how it should work. So like those are like, just things that there's no reason not to be tested super well.
Well, you say that, but parsing X509 is difficult and has been fraught with problems throughout history. And you actually, in your blog, authority statement, you specify that you now have a pure Rust parser for X509, which is super cool because now you can't have buffer overflows in your X509 parsing.
Yeah. I mean, we get no buffer overflows. And also, I mean, I don't know how much we want to go into like the stuff we've done with Rust, but like one of the other big benefits we've got is Rust's safety with respect to lifetimes makes it really easy for us to do things like every like sub-component of an X509 certificate is just a pointer back into the original buffer. So, you avoid all sorts of allocations and copying in order, which like gets you a bunch of performance. And like it's one of those things where like you can absolutely have pointers into an original buffer in C. There's no question that's technically possible, but we're able to do that with a high degree of compile time safety, right? No risk of, the pointer you got out of the subject accidentally outlived the original buffer. Like we just don't have those risks, and we get the performance wins.
Yeah. I mean, look, let's talk about your Rust actually, because actually yesterday on the calendar, but sometime before this episode, I talked to Celeste, who's the author of the Rust core utils that are going into Ubuntu now by default. We talked about all like the magic things kind of Rust gives from a security perspective, but he like points out it's not just about security necessarily, because like Rust is fun, and also like it's attracting a younger crowd, we'll say, versus a lot of C. So yeah, I mean, tell us about your Rust. Like, what are you doing? What do you want to do with it? What's kind of give us the down low.
So back in I guess it was probably mid 2020, right, Alex? I think that's when we started really seriously pursuing what does it look like for us to increasingly oxidize our project. So at the time, PyO3, which is the Python Rust bindings, already existed and was a very good project. David over there continues to do fantastic work. But it had never shipped in a really high profile project, which meant that there was a lot of questions about what does it mean? What are the adoption costs? Python has both like source distributions and binary wheels. Wheels are the binary distribution artifacts that you can produce. A lot of that in 2020, 2021 was not as mature as it is today. And so Alex and I went down this path. We decided that this was worth it from both a security and developer ergonomics perspective, and that we were going to figure out what it meant to kind of eat the pain is the terminology we use. Like we would eat the pain as a project. We would figure out what the blockers were. We would go and like move the ecosystem forward such that we could keep doing this, and also that we could unblock other projects in the future so they could more fearlessly make this migration. So we notified folks of our intent in late 2020, and then we shipped our first release, which had a Rust component that did nothing. So you could actually compile it back out if you didn't want it, in February of 2021. And there were a variety of things that came out of that. There was a few. I think there was one relatively heated GitHub thread, but other than that, it was generally pretty good. And we moved forward and we fixed a variety of things. And frankly, the ecosystem stepped up and did a bunch of work too. Like at the time, there was no mechanism of shipping wheels on Muscle Linux, which is of course important for Alpine, and that was resolved. And there was a variety of other areas where like the compilers weren't quite in the shape we needed them to be, or they weren't bootstrapped inside of the Linux distro. And all that stuff actually changed over the course of a few years, including what Alex and I consider our perhaps undeservedly, but we still consider it one of our crowning achievements, which is that IBM shipped Rust on AIX, and one of their headline statements in that shipment was that you could compile cryptography.
Nice. Okay, so let me ask a technical question then. So like you wrote an X509 parser in Rust, like why not just make it like pure Python?
Yeah, I mean, the biggest reason to not do X509 or like any of the other stuff we've done in Rust in pure Python is performance. Python is like not a particularly fast language. I used to be like a Python performance person. I worked on pyca and unladen swallow before that. Like I would love for it to be possible to just like write high performance Python, but like that's not the case today. You'd be giving up probably at least 10x performance.
Whoa, that bad.
And like I honestly could be worse. Like, it wouldn't surprise me if it was worse. And like, I think one of my beliefs is like, for better or for worse, for lots of organizations, cryptography is like a thing they add on after the fact, right? They design some system, and they're like, oh, now we got to add the security after we've already built it.
Yep.
And like, that is unfortunate. I would like to not live in that world. I'd like security to be like a consideration from day one, but it's not. And like, I don't have the, we don't have the tools to make that be the case. And so as a result, it's like really important that when people go to add the cryptography, it doesn't like make whatever they're building so much slower that they're like, maybe I should skip this. So like,
Sure.
we think cryptography needs to be fast, primarily so that it is never the performance is never the reason somebody shouldn't encrypt something or sign something or, whatever.
I would also note on that one just that, like, per the conversation earlier around us doing this because it's fun, is that the Rust side of this of this work is a lot of fun.
Yeah.
Like, we get to play with really high performance things. We get to like go and say, well, how can I design this in a manner where we can ensure that it never does any allocations? And like, obviously in the Python world, part of the reason why you get that 10x or worse slowdown is there's going to be an awful lot of allocations inside of the slab allocation that Python itself is using. But like, everything's an object. There's lots and lots of other overhead components. Every time you allocate an object itself, you're going to have like a dictionary that gets allocated. There's just so many things, and it's much easier to reason about like, here's how this is going to work, and this is like the exact memory layout that we're going to expect when we allocate this struct in Rust.
Yeah, and I would say like we can do that performance work in like very idiomatic Rust, whereas people who attempt to do like high performance, like truly in Python, not like with something like NumPy or something like that, like high performance, like looks like less idiomatic Python. So like, it's also, by using a language designed for performance, like we kind of don't have to take that trade-off between idiomaticness and performance.
Yeah. And good luck with constant time in Python, right?
Sure. For things that like are, even more cryptography, things like we have like unpadding done in Rust for like a symmetric encryption, like message padding. Like there's no way to do that in constant time in Python. Like it simply has to be in a language that affords you more control.
Yeah.
Like,
Yep, for sure. Okay, so I want to kind of land this plane asking what's next, because I'm curious, like, has OpenSSL taken any steps to address some of the issues you're talking about? I know you mentioned in your statement about potentially dropping OpenSSL in favor of one of the forks we talked about. I'm curious, like, what's going on now, because it's been basically almost a month since you wrote this. So I'm curious what's happened since then.
Yeah, so we know many of the OpenSSL developers have been kind of discussing kind of the issues we raised on forums, and we'll let them just speak to kind of what they're thinking in terms of their direction. But for us, we kind of laid out a couple of next steps for us, and the kind of the immediate term one is, historically our kind of unwritten policy is like, we don't ship functionality that doesn't work on OpenSSL, right? Like, everything's got to be there. Like, might not necessarily be on all the forks, but like, got to be in OpenSSL at least. And we're going to pull back on that policy. And in our next release, we're hoping to ship post-quantum cryptography, probably
Nice.
MLChem and MLDSA. And the implementations there will be probably for the forks only, or like maybe a subset of the forks. Like, we haven't figured out the exact details, but we're not going to try to do OpenSSL first for those. We're gonna figure out our APIs and testing and documentation. We'll do all those kind of for the forks first. That'll be what's in the release, and we'll see if OpenSSL kind of comes afterwards. But we found that like having OpenSSL be the blocker to doing these is, it's just exposing us to a lot of the kind of API frustrations we talked about at the top. So that's kind of the immediate term.
So can I ask a quick clarification on that? So if you're going to support the post-quantum crypto, are you going to also ship the forks in the wheel, or are you going to still ship OpenSSL in the wheel?
Yeah, we're going to still ship OpenSSL in the wheel, which is going to be this very awkward thing that many of our users will not have access to
Gotcha.
kind of the new functionality. Like, we're like conscious, like we're not wild about that, but like that's kind of balancing
Sure.
the backwards compatibility impact and trying to like make forward progress. This is kind of like the next step. But yeah, the kind of next step after that is figure out what would it take to migrate our wheels. And there the big question is like, the wheels all have different subsets of OpenSSL's functionality, and figuring out what are we comfortable dropping, what can we maybe encourage one of the forks to add, how do we minimize the kind of potential features we're giving up by switching to a fork.
Yep. And the timelines for that start getting longer than Alex and I would like, but probably shorter than many of our consumers would prefer. So like the goal here is not necessarily, if OpenSSL doesn't, bow to our demands and the ways they need to change the direction of the project, that we're going to be gone in 6 months. Like this is a multi-year effort. And like OpenSSL, we recognize that OpenSSL as a project it takes a while to turn a ship. And so if they choose to turn it, like we are ready and willing to stay on it if it makes sense. If it does not, then like we are taking steps to protect ourselves and our users in the medium to long term future.
Right. And I mean, we should also just note, like, cryptography is not the only OpenSSL user. Like, they have an army of users, beyond the gates and all of them have complaints, right?
Yep. I mean, OpenSSL is in many ways they are probably the most widely used cryptography library in the world. Yes, it's absolutely like they have a multitude of users, all of whom have ridiculous, like sometimes mutually exclusive requirements in the way they need to operate. It is genuinely a challenging project to move forward in a meaningful fashion. The challenge we have, of course, is that like they did move the needle, and they spent a lot of time and energy changing things, breaking their ABI, and moving it to a new model. And unfortunately, we think that new model is actually substantially worse.
Right on. Yeah. I for what it's worth, I don't know anyone who likes OpenSSL 3. Like, that's just, in my experience, I feel like whatever they think they did to make it better, a lot of users do not agree, which is fine. Their project, they're allowed to do it. But okay. All right. I will let the two of you bring us home. So let us know if there's anything you want us to know, if maybe anyone's interested in the project and they want to learn more, getting involved, using it, getting started, kind of whatever. I'll give both of you the floor to end the show.
Sure. So this project is hosted at github.com/pyca/cryptography. We're always welcome. All users are welcome to come and file issues or bring pull requests and things of that nature. We host our documentation at cryptography.io, where you can see our statement along with all the docs and the ways in which we develop the project. And I guess the last thing I'll mention before I hand it over to Alex is that it is our sincere hope that the OpenSSL project will adopt many of the things we're talking about. And one of the things that can help that happen is folks like those listening to this podcast going and very respectfully getting involved with OpenSSL. Like the purpose here is not harassment. The purpose here is not to tell them that they're doing anything wrong. That is not an effective means of advocacy in any open source project, and it's offensive, frankly. The thing to do if you want to get involved and affect positive change is to come and bring your ethos, your opinions, and your effort.
Yeah, I don't have terribly much to add on top of that. Just we're always enthusiastic for new contributors, both to our library itself, but also to, I think, other like good projects in the cryptographic ecosystem. If you're interested in like cryptography standardization, for example, the Community Cryptographic Standards Project is like a great place to contribute to improve the quality of testing for like the entire cryptographic ecosystem. We help maintain and support a library called X509 Limbo, which is like a set of test vectors for X509 path validation. Just like, we're love it if folks want to contribute to us, but also like there are many kind of, libraries and test frameworks we consume that we're also enthusiastic for people to contribute to.
Right on. All right. And I will put links to all this stuff in the show notes for anyone interested. So just go to the show notes and they'll all be there. So, all right, Paul and Alex, this has been a fantastic discussion. I want to thank you both for the time. I truly appreciate it.
Thanks so much for having us,
Josh.